Recording. Alrighty. Really quickly, Issa, are you able to hear me?
Yes.
Okay, perfect. So before we begin, how was everyone's past day? Anything fun or exciting that you'd like to share before we begin? Just kind of a good regular day then? Oh, well, that's okay. Let's let's kind of hop in then. Yes, let's start with Issa. Did the homework make sense? Was there anything that you wanted to focus on? Any questions that you had um, that you wanted to take a look at?
The homework made like sense, I think.
Okay. Was there any part of it that maybe was a little tricky or that you wanted to maybe look at? Any questions that were a little tricky that you didn't get right away?
I think like some questions on like the second part, but then like I figured it out.
Okay. Was there anything you wanted to review?
I think it's okay.
Okay. Masha, was there anything that you wanted to take a look at?
For me, everything made sense, but do we have to like email a photo of the homework to you?
Um, let's let's do that for now. Or you don't have to do it for this one, but let's do that for the next sessions. Just so that we can kind of review and then obviously like I said, the answers are on the sheets there. But I would like if you could just kind of mark ones that maybe you didn't get right away, and that'll just tell me what, if a lot of people are having trouble with a certain part, that could be something that we review. Does that sound good?
Yeah, thank you.
Okay, and then Helena, did you say that you were able to do the homework? It made sense. Was there anything you wanted to ask?
It made sense.
Okay, then let's today, just because I want to make sure that we get through everything, let's kind of hop in on what we're going to talk about today. So we're going to talk about angles. And the very first thing I want to talk about is let's draw our standard X, Y plot, or standard axis. And very quickly, I'm just going to label these quadrants. That's quadrant one. This guy's quadrant two. Over here is quadrant three. And right here is quadrant four. And the very first thing we learn is, and let's maybe start with this. If I told you that I have an angle, let's call it 130 degrees. Where am I going to put this angle? What quadrant does it go in?
The second one?
Yeah, it's going to go in the second quadrant. And here's how I'm going to draw it. So I'll put it somewhere right about here. And I'm always going to draw, we call this, let me make a little more space here. We call this our standard angle. And what is a standard angle? A standard angle starts at the x-axis. So 0 degrees would be right here along the x-axis. And we go positive direction is counterclockwise. And this is theta. This is our 130-degree angle. It measures from, we call this the initial side. And the initial side is always our x-axis. And we call this the terminal side, and that's where our angle is going to lie. And what we really care about is where is the terminal side? What quadrant is it in? Um, and just really quickly for reference, if I told you that I have a new angle, let's call it alpha, and let's say that that's negative 130 degrees. Where's that angle going to go? Can somebody tell me? What quadrant would that be in?
The fourth one?
Not the fourth, but I think you're on the right track. So positive direction, we go counterclockwise. Negative direction, we do the exact same thing, but going clockwise. And it's going to end up in our third quadrant. Okay, so this is alpha. Let's actually make this a different color. Does that make sense? So Which Issa, which direction does the positive side? Is it clockwise or counterclockwise?
Counterclockwise.
Exactly. And then really quickly, Helena, are you able to turn on your document camera?
I'm just using my phone. I don't have another camera.
Okay. For the future, if we're able to, we could figure that out a little later, but maybe figuring out so that we're able to, oops, sorry about that. My screen just stopped sharing. Figuring out so that we could see your work and you're able to follow along with us. But we'll talk about that later. Let's for now, sorry, let me hop back on there we go. Are you able to take notes? Are you able to maybe turn your camera on? Or you said you're just on your
Um,
phone for now?
yeah, I'm just on my phone for now.
Okay. Okay, we could figure that out then, for the future, just making sure that you're able to follow along. But are you able to see everything okay?
Yeah, I can see everything.
Okay, awesome. All right. So let's now talk about what we care about today. That's kind of a little bit of a view of our angles. Today we're going to be talking about our reference angles. And our reference angles are basically anytime we have an angle that is not acute. What is an acute angle? An acute angle is an angle that is less than 90 degrees. So if we don't have an acute angle, we have an angle like 130 that's greater than 90 degrees. We want to figure out what its reference angle is. And we're going to draw again our standard XY. And in each of these quadrants, so let's say we're in quadrant one right here, well, then our reference angle is just our regular angle. So I'm going to call our standard angle alpha for now. And our example will still be 130 degrees. And we'll call each of our reference angles theta. So if our angle is in quadrant one, well, then we're good. Our reference angle is um, our standard angle. Theta is equal to alpha. This is the standard angle, right? So alpha is what we are given. Okay. If I am in quadrant two, all the way over here, this is alpha, right? We just talked about that, but that's not my reference angle. My reference angle is, and let's make this a different color so it's a little more clear. Our reference angle is this guy right here, theta. And how do we find theta? Well, in quadrant two, it's not equal to just alpha anymore. It's equal to, well, we know that right here is 180 degrees. So it's 180 degrees minus our given angle, alpha. Any questions so far? So the whole idea of our reference angle is that it's the angle that is sandwiched uh, between the x-axis and our terminal side, or sometimes we call this the radius. Okay, and that's this line right here. That's what I'm talking about. So let's see what happens in the other quadrants. In this quadrant right here, quadrant three. So here's quadrant two, here's quadrant three. In quadrant three, well, this is the angle that's sandwiched between them. And how would we get that? Well, in this angle, in this quadrant, the angle is our given angle minus 180 degrees. Because, why is it that? Well, here is 180 degrees, and this green one is our angle. And if I want the red one, I just take the green one and subtract it from the pink one. Same thing over here. If I want this red angle, well, I take this green one and subtract it from the purple one. All right, can somebody maybe tell me what do we think we're going to do to find our last theta? What would this equation be? This is in quadrant four. How would we find our reference angle here? Maybe, Helena, do you have an idea of what maybe we could do here? Let's think about
Uh,
what we want. We have this purple, so let me get rid of this alpha. We have this is what I'm giving you. I'm giving you this big angle right here, and I want to find this red one. How can I do that?
Do we minus the one in the the purple one in the middle? 180 minus the purple one in the middle?
Not 180, right? Because
Oh,
180 is just this right here. So if I do 180 minus the purple, I'm going to be left with this right here. And it will be negative because I'm taking a bigger number, right? The purple one's going to be bigger than 180. But maybe if I took this green one that goes all the way to the end and I subtract it from that purple one, I'll be left with the red one right here. What is that green angle I just drew? How many degrees is that?
360?
Yeah. So we're going to take 360 and we're going to subtract it by our given angle. And this is what we do for each of, I'm sorry, let me make this red. This is what we're going to do for each of our quadrants. If we're in quadrant 1, the angle we're given is our reference angle. If we're in quadrant 2, our reference angle is 180 minus the angle we're given. If we're in quadrant 3, it's the angle we're given minus 180. And the reference angle in quadrant 4 is 360 minus alpha. Okay, so write that down and let's actually look at an example of the first section we're going to talk about today. So section 1 is all about, is all about sketching reference angles. And let's go through this first example together. So for example 1, I want to sketch 120 degrees. And here are going to be these steps. The very first thing we're going to do, or actually, let's call this the very like pre-step, because this step only applies if you're given radians. You're going to convert from radians to degrees. If you're already in degrees, you're good. Now, you can do this in radians, but since we're not masters of radians yet, we're going to convert it to degrees because we already know that this is 0 degrees or 360. We know that this is 90 degrees. We know that this one is 180 degrees, and we know that this one is 270 degrees. But maybe we haven't yet mastered that this is 0 or 2 pi radians. This is pi over 2 radians. This guy is pi radians, and this guy is 3 pi over 4. 3 pi over 2. If you feel like you start to master understanding where the radians are, which one is quadrant 1, 2, 3, and 4, then we can skip this first step. But for now, just while we're still getting used to understanding radians, since it's like if you were asked to start using Celsius instead of Fahrenheit, it might take you a little bit to get used to it. Eventually, though, we really, really, really want to understand everything about radians. We want to be able to use radians as easily as we use degrees. But for now, let's take a step back and we'll do a conversion first. Okay? Then our very first step is going to be to sketch the given angle in standard position. Okay? And all that really means is we're going to make sure we put it in the correct quadrant. So, Masha, where would this guy go? Where does 120 degrees go? Where am I going to draw that terminal side or that radius?
In the second quadrant.
Yep. So let's draw that guy right here. And we're doing this. And then step 2 is going to be to draw our triangle. And when I say triangle, that's the triangle that goes to the origin and to the x-axis. What do I mean by that? Well, that triangle is this guy right here. We go to the x-axis and then to the origin. And now we have our right triangle. For now, we don't care too much about this right triangle because all we really care about is finding theta. But if we remember what we were doing last time, we were using this right triangle to find some really interesting things about this point right here. And this class, we're going to start really, really, really using some interesting trig functions in order to find out information about where this point is or where this angle is, what side this is, depending on the information we're given. So it's super, super important that we draw this triangle. Then step number 3 is going to be to find our reference angle, theta. And let's do a quick little recap. So we are in which quadrant? I know you just said it. Masha, can somebody else tell me what quadrant are we in? Um, Maybe Issa, what quadrant are we in? Issa, I think you're still muted.
Uh,
Mhm.
uh,
Which quadrant is this line in? The red line, or terminal side? What
uh,
quadrant is that?
uh,
It's okay if you don't know. So let's remember this is quadrant 1, and we count going in the same direction that's positive. We count counterclockwise. So if this is 1, what would this one be over here?
two,
2. And right below it would be 3. And right here would be 4. Okay, so 1 is our first one. That's going to be our where x and y are positive. Number 2 is going to be where x is negative and y is positive, right in this corner. Our bottom left corner is going to be 3, where x and y are both negative. And in quadrant 4, we're going to have y negative and x positive. All right, and can you take a look at what we were writing earlier? How do we find theta? What is our reference angle equal to in quadrant 2? So in quadrant 2, what is the formula to find this theta right here? If we are given our given angle, which we know right here is 120 degrees. Isa, what do you think we need to do?
six.
Mhm.
um, that minus 180.
Um, well, let's take a look. Is it that minus 180 or is it 180 minus that? Let's see what goes on in quadrant 2. The 180 goes first, and then we subtract that angle we care about. Why? Well, because we want to take this big chunk, the green chunk, which is 180, and get rid of the blue chunk. And if we do that, we're left with the purple chunk. Does that make sense?
Yeah.
So can you repeat that with me? When we are in quadrant 2, it's going to be 180 degrees
mi-
minus our given angle.
Minus the given angle.
Perfect. Okay, so then this would be 180 degrees minus 120 degrees. So then, Helena, what is our theta?
Is it 60 degrees?
Yep, that's going to be 60 degrees. And that's it. That is the main 3 steps for solving our first angle. Or for sorry, sketching our reference angle. Let's do for example 2. Let's do negative pi over 6. And let's ask ourselves, what is this guy become? Or sorry, I lied, that's not negative. Let's do 7 pi over 6. Let's try this one. So let's figure out where this guy is. What is the first step we need to do to figure out where 7 pi over 6 is?
Convert the radians into degrees.
Yeah, actually, I lied. I'm sorry. Let's make this negative because I want to explain what happens if we do a negative angle. Yeah, so the very first thing we're going to do is convert radians to degrees. Can somebody remind me, how do I do that? What do I need to do to take this guy and convert it into degrees?
Do you multiply it by 180 degrees over pi?
Exactly. We multiply by 180 degrees over pi. How do you know if it's 180 degrees over pi or pi over 180? Well, If you're in radians, we want the pi's to cancel. And if you're in degrees, we want the degrees to cancel. So in this case, the pi's on the bottom and the pi's on top, we're good. So that's maybe one way to remember it. But as long as you remember, yep, the thing that you want to convert to goes on top. The degrees are on top. If I wanted my radians, I would put the pi on top. Okay. So let's do this first. And we can see that this and that cancels, and this becomes 30 degrees after we divide by 6. So we're going to get -7, and of course our pi's cancel out. So we're going to get -7 times 30 degrees. And what does that become? What angle is that?
-210 degrees.
Perfect, -210 degrees. All right, if we want to, we can easily just say, all right, well, we know how negative angles work. We can graph that. But there's something, I believe I talked about it last time, but if I didn't, we're going to review it right now. We're going to talk about something called a coterminal angle. I'm going to explain this super, super quickly. But let's say that right here, I have, let's call this guy, uh, uh, let's say that this guy right here is, we'll do this one. This guy right here is -30 degrees. That's one way to write this angle. But we can also say that this angle is positive what? That would be 330 degrees. These both represent the exact same angle. -30 degrees is equal to positive 330 degrees. They are coterminal. Coterminal meaning they share a terminal side. Anytime you want to find a coterminal angle, all you need to do is take your angle that you have and add 360 degrees or subtract 360 degrees. And you can do this as many times as you want, and you will get the exact same angle. Let's see that really quickly. If I take -30 degrees and add 360 degrees, I get 330. They are the exact same angle. If I took 330 degrees and subtracted 360 degrees, I would get -30 degrees. And in fact, you can keep doing this. I could subtract it again and I would get negative 390 degrees. And that would be the exact same angle. If -390 degrees would be like this. Both of those are coterminal angles. The reason that we are talking about this is because maybe I don't like negative angles. Maybe that's a little confusing for me. So I'm just going to add 360 because I know that I can always add or subtract 360 degrees and it will give me the exact same angle. And what does that equal to when I add 360 degrees? Can somebody tell me what -210 plus 360 degrees becomes? Um, Maybe Masha, do you wanna chime in?
1 second.
No,
150 degrees.
perfect. 150 degrees. That is the angle that we're going to use. It's going to be the exact same as this one, and it's the exact same as this one, but that's maybe the easier way to write it. All right. Helena, can you tell me what quadrant is 150 degrees in? Where am I going to draw that terminal side?
Number 2.
Yeah, exactly. We're going to draw this in quadrant 2. So let's draw it right here. And we'll say that we know that this is 150 degrees. All right, so we did step 0, 2 degrees. And then we did step 1, we sketched the angle. What is step 2 asking us to do? We need to draw what?
The triangle to the x-axis.
Perfect. So we're going to draw straight down to the x-axis, and then we're going to draw straight over to the origin. And we'll just say we know that this guy is a right triangle, and that is the angle, the reference angle that we care about. All right, so we drew our triangle. What is the last step? What do we need to do here?
Find the reference angle.
Yeah, we're going to find our reference angle. So we know that theta is equal to what? What is our reference angle here?
180 degrees minus 150 degrees.
Perfect. And that gives us 30 degrees. So we know that this guy right here is 30 degrees. Okay. Any questions on that? Can everyone give me a thumbs up if that makes sense? Awesome. And then Helena, does that make sense?
Yeah.
Okay. Let's do this now. Let's do one practice problem. Can you all take 5 pi over 4 and um let's draw that reference angle and let me know what you get. If you need some help, you can raise your hand. I'll give you about 5 minutes and then I will start solving it. I'll give you 2 minutes and then I'll start solving it. So if you feel really stuck, you can watch me go through it in a sec, but I want to give you guys a chance. Alrighty. I'm just gonna start kind of going through it. So the very first step we know is going to be to convert to degrees. And in that case, that's just 180 over pi. Our pi's cancel out, and our 4 and the 180 becomes becomes 45, right? Uh so we have 5 times 45 degrees. And 45 times 5 is going to give us 225 degrees. So that's our first step, or our step 0, to convert to degrees. And all right, well, we know that that's greater than 180, but less than 270. So it must be in quadrant 3. So we'll draw that somewhere over here. And we'll call this, actually, let me draw it a little bit over here. We'll call this our 225-degree angle. The next step is to draw our triangle. And I saw, it looks like you both got that. Helena, can you tell me what we do after I draw this angle? I want to find theta, right? So there's our theta, there's our right triangle. Can you tell me what formula do I use to find that reference angle? What is theta equal to?
Uh, I think it's 225 minus 180.
Perfect. Yep. And what would that be?
45.
Exactly. So our reference angle is 45 degrees. And that's it. That is all we need to do to draw a reference angle. Masha, Nisa, can you give me a thumbs up if that's what you got, or if you're almost there? Perfect. Perfect. All right. Let's now move on to talking about our next section. So section 2, we're going to now talk about sketching and finding our 6 trig functions. Okay, so we're going to recall what we did last time. When we are given a point. Okay, so let's start with this example right here. I'm going to give you the point -3, -6. And the very first thing we're going to do, so step 1, is going to be to sketch our triangle. So in order to do that, we got to first plot that point. So right here, I'm going to draw, let's move this guy over a little bit. We have, let's do 1, 2, 3, and 1, 2, 3, 4, 5, 6. And let me draw that guy a little closer. And we're told that we're at -3 on the x and -6 on the y. So that's going to be a point right there. So this point right here is -3, comma, -6. And we're going to draw the triangle. So the triangle goes straight up. And it looks like I drew that a little off. So let me make that a little more clear. And straight there. And then we draw our terminal side. And we say, all right, we know that this guy is going to be theta. And this guy right here, we know is a right angle. And let's draw the lengths of our side. This is -3, and this is -6. So that is the very first step is to, the very first step is to draw the triangle. And then the second step is to label the sides. Okay, label the sides and theta. Then we need to, for step 3, we need to find our hypotenuse using what? Can somebody remind me? How can I find this hypotenuse? Let's call it r. How can I find the length of r?
Pythagorean theorem.
Yeah, so can somebody tell me r is going to be equal to what? Maybe, Masha, can you tell me what would r be equal to?
The square root of -3 squared plus -6 squared.
Yeah, and I'm gonna refer to it in terms of x squared plus y squared, just because that is for anything that we're given. But for this specific problem, yeah, r is equal to the square root of -3 squared plus -6 squared. And let's do that real quick. We see that that is going to be the square root of 9 plus 36. And 36 plus 9 gives us the square root of 45. Okay. What do we know about 45? Can we simplify this at all? There's nothing wrong with this, but sometimes we want to write things in our most simplest form, which would be what? Can we break up 45 into a multiple that is a perfect square?
9 times 5.
Exactly. So we'll break this up into 9 times 5. And then what does that become? What happens to that 9?
It goes onto the outside as 3.
Exactly, because the square root of 9 is 3. So that's 3 square root of 5. And boom, we found our hypotenuse. All right, step 4 is going to be to actually put it right. Drawing our reference angle was part 4. My bad. As long as you do all these steps, you're good. But sorry, draw our reference angle. That's step 4. Okay, and now we have everything we need to find our 6 trig functions. Let's remind ourselves what they are. Let's start with sine of theta. Using what we remember last time, what is sine of theta in terms of, and let's call this really quickly, what side is this? It is on which direction from theta? What do we call that? We call this the what side?
Opposite.
Yeah, and then we call this one the adjacent. And then, of course, r is our hypotenuse. All right, So what is sine of theta? What do we remember about that? Maybe Helena, do you remember what sine of theta is?
Um, is it what's it called? Opposite over hypotenuse?
Exactly. And in this case, what is opposite over hypotenuse? What does that become?
Um, -6 over 3 square root 5.
Yeah, and if we wanted to, we could simplify this. These cancel out and we can radicalize it. And we will get that this is -2 square root of 5 over 5. Okay. Then let's ask ourselves about cosine of theta. Isa, what is that one? What is cosine of theta?
Is it adjacent over hypotenuse?
Yes, no worries. It is adjacent over hypotenuse. Perfect. And in this case, that would be -3 over 3 square root of 5. And if we do the same thing, these cancel and we radicalize, then we get that this is equal to negative square root of 5 over 5. All right, let's do tangent of theta now. And Masha, can you tell me what tangent of theta is?
Opposite over adjacent.
Perfect. Opposite over adjacent. And that would be -6 over -3, which is just 2. All right, well, now let's ask ourselves for our other three, our reciprocal identities. What is cosecant of theta?
Hypotenuse over opposite.
Exactly. That's going to be hypotenuse over opposite. We just flip that one. And in this case, that's just 3 radical 5 over -6, or radical 5 over negative radical 5 over 2, or over -2. And that's just because we did that. And what about secant of theta? What do we remember that one is?
Hypotenuse over adjacent.
Exactly. That's going to be hypotenuse over adjacent. And in this case, our hypotenuse is 3 radical 5, and our adjacent is just -3. So this would be negative radical 5. All right, our very, very last one. What is cotangent of theta equal to?
Adjacent over opposite.
Exactly. That's going to be adjacent over opposite, or -3 over -6, which is 1/2. All right, let's have you guys try an example. Or let's do this one kind of together. Just because I want to speed through so that we can make sure we cover everything. Let's do, this is going to be 3, -2. And this is what we want to find the 6 trig functions are. So we're doing the exact same thing, but now we're starting with 3, -2. So, Masha, what's going to be our first step? So I'll draw an XY for us. And what am I going to do?
Like plot the coordinate and sketch a triangle.
Yeah, so can you tell me what quadrant is this going to be? And let me draw some little ticks here. So 2, 3, 4. Let's do 1, 2.
The fourth quadrant.
So we're going to have on the X, 1, 2, 3, and on the Y, -2. So we're going to be right about there. And this is the point 3, -2. And then you said I draw my triangle. So let's draw our side R. And then let's draw this side. And then let's draw that side. All right, Isa, can you tell me what step 2 is? What are we going to do next?
Label the sides.
Yeah, so let's start with this side right here. What goes there?
Wait, which side?
This one right here.
Negative, -2.
Perfect. And what about this side right here?
3.
All right. And then, Helena, what do I do next? What's my next step?
Um, do we have to label the angle?
We could do that now. Technically, the way I wrote down this in the notes, that's supposed to be step 4, but as long as you label that angle, that's good. We're missing one
Oh,
other thing. What do we got to do next?
find R.
Exactly. So what is R equal to?
Um, -2 squared plus -3 squared. I mean, plus 3 squared.
Plus 3 squared. Perfect. But that's what R is. I mean, sorry, that's what R squared is. What is R? What do I have to do?
Oh, the square root of that.
Perfect. Yep. So that would just be the square root of what's 2 squared?
4,
And then what's 3 squared?
9.
All right, so that's the square root of 13. And then from here, if we want to find the 6 trig sides, we would do the exact same thing we did. And I believe that you are capable of this. For the sake of time, I'm going to move on. But you do the exact same thing in here. You just plug in each of your sides to whichever trig function we have. Any questions on this? Anything that doesn't make sense? Or is this good? Everyone give me a thumbs up if this makes sense. All righty. Let's take a look at section 3. So the next thing we're going to talk about is going to be understanding the sign. When I say sign, I mean positive or negative of sine, cosine, tangent, and these are going to be the same sign as cosecant, secant, and cotangent. Those are related. They're related in the fact that if tangent in a certain area is negative, well, if I just flip a negative fraction, it's still going to be negative. Does that make sense? So those are all related. And this is figuring out the sign of them in each quadrant. All right, let's talk about what I mean really quickly. So, big thing here that we want to think about is let's understand quadrant 1 first. What's going on in quadrant 1? When I have my angle in quadrant 1, let's draw this with a little purple. And I have this is theta, and I have this side right here, which we're going to call this the y side. Why? Well, because this point right here is x comma y, and the height of that must be y. The length of this side right here must be x. So whatever that point is, the length of this is x, and the length of this is y. And of course, that would be our opposite side, and that's our adjacent side. And right here, we're going to call this guy the hypotenuse, or sometimes we'll call it r. But I'm going to specifically call r equal to 1. I'm going to say that this is going to be a length of 1 for now. If this is a length of 1, well, let's take a look at what happens. Sine of theta is just equal to what? If this is 1, what is sine of theta equal to? So, Isa, what do we know about sine of theta? What equation is that?
Opposite over hypotenuse.
Yeah, and in this case, the opposite is y, and the hypotenuse is 1. So sine of theta must just be y. Now, of course, if this was not 1, this was the letter r, well, then it would be y over r. But for now, we're going to pretend that it's 1. And this is going to lead us to our next topic, which is super important. But yeah, let's look at cosine. That one's just adjacent over hypotenuse, which in this case would be x over 1, or just x. And then tangent of theta is going to be opposite over adjacent, which is y over x. So that gives us our nice little cheat sheet that sine of theta
is the y coordinate. Cosine of theta is the x coordinate, and tangent of theta is y divided by x. This only works when r equals 1, okay? When we have what we're going to call a unit radius. The word unit usually refers to things that have a value of 1, okay? And let's quickly take a look here. That's what happens in quadrant 1. But what happens if we were in other quadrants? Well, in quadrant 1, we know that x is positive, so sine of theta must also be positive. Cosine of theta must also be positive since x and y are positive in quadrant 1. Helena, what is x and y in quadrant 2? Which one is positives and which one is negative? Or are they both positive, both negative? What is the signs of x and y?
I don't know, but are they positive?
Well, let's think, how can I get to this point right here? Which direction do I need to go on the x-axis?
Oh, negative.
And which direction do I need to go on the y-axis?
Positive?
So we know that x is positive. So, I'm sorry, y is positive. So sine of theta must be what?
Negative?
Not negative. What is
Oh,
sine of theta?
positive.
But what is sine of theta the same as?
Y.
And if sine of theta equals y, and we said that y is positive, well, then sine of theta is also positive. What about cosine of theta? Is that one positive or negative?
Negative.
Why?
Because it's the X
Exactly.
and it goes on the other side.
Isa, can you tell me what about quadrant? Oops, that's quadrant 3. What about quadrant 3? What do we know about sine and cosine in quadrant 3?
Are they both negative?
Exactly, because x and y are negative. Sine will be negative, cosine will be negative. What about quadrant 4? Masha, can you tell me what goes on in quadrant 4?
Cosine would be positive and sine would be negative.
Cosine would be positive and sine would be negative. Perfect. And let's now ask ourselves about tangent. Now remember, I told you that tangent is equal to y divided by x. But we know that y is just sine of theta and x is just cosine of theta. So it's just sine of theta divided by cosine of theta. Well, if they're both positive, that's a positive divided by a positive. So right here, we know that tangent of theta must also be positive. But over here, one is negative and one is positive. So tangent of theta must be negative. What about when they're both negative? What's tangent of theta going to be?
Positive?
Yeah, because it's a negative divided by a negative. And a negative divided by a negative is a positive. What about over here? If I have a negative divided by a positive.
A negative?
Exactly. Okay, so this is important for us to understand what's going on here. Let's take a quick example to understand why this is so important. Let's take a look at cotangent of theta. So I'm going to tell you that cotangent of theta equals 1. Sine of theta is going to be less than 0. That means what? That sine of theta is negative. And cosine of theta is less than 0. Well, if sine is negative and cosine is negative, what quadrant are we in? What quadrant is that?
Wait, could you say that again?
Sine is negative and cosine is negative. Which quadrant is that? 1, 2, 3, or 4?
The third one?
Exactly. They're both negative, so we must be in this quadrant. So anytime you are given, this is an example where we're given the signs of our trig functions. We then use this to figure out what quadrant we're in. We must be in quadrant 3, since they're both negative. Now what we need to do is use the facts about cotangent to draw our triangle. So we could draw our triangle, but we need to figure out what the sides are. So what does cotangent tell us? Cotangent tells us what? Cotangent is equal to what about our sides? This is the opposite side and this is the adjacent side. What does cotangent tell us? Let's do Helena. Can you tell me what does cotangent tell us?
Is it does it tell us the adjacent over opposite?
Yeah, it tells us the adjacent over the opposite. And in this case, we're told that that's just 1. And 1 is the same thing as 1 divided by 1. So what does that tell us about the adjacent and the opposite side? What are they equal to?
1.
Yeah, they're both just 1. So this must be 1 and this must be 1. And then I can ask you to find right, our hypotenuse r. And if you do that, that's just square root of 1 plus 1 squared, which is just square root of 1 squared plus 1 squared. And that's just, I'll write it all out. R is equal to square root of 1 squared plus 1 squared, which is both of those just 1. So that's square root of 2. And then from there, I can ask you maybe to find theta. How would you find theta? Well, we could say that maybe we know that tangent, right? Or we know that tangent is also equal to 1. Why? Well, that's just 1 divided by 1. Or we can use the fact that it's the opposite of, or the reciprocal of this. And then maybe if I want to find theta, we do inverse tangent of 1. And when you plug that into a calculator, we will get 45 degrees. All right, I want to make sure that we have time to get to the last topic. So I'm going to skim through or skip over this, but a lot of the homework is going to have problems like this. The big thing to do is to first figure out from what you're given here. So for example, if I'm given tangent of theta is less than 0 and sine of theta is greater than 0, what quadrant are we in? What quadrant must we in if sine is positive and tangent is negative? What quadrant is that? Maybe Masha, can you tell me what quadrant will we be in if tangent is negative and sine is positive?
The second one?
Exactly. So for these types of problems, the first step is to figure out what quadrant you're in based on this information. You'll get different versions of this, but all they're going to be is just figuring out, just look at your table here and figure out which quadrant it is. Then you draw your triangle like we would doing any of these steps, right? Any of these steps here. And then you figure out from this guy, all right, what information does that tell me about the sides of my triangle? Then you fill in those sides. And then if you're trying to find, for example, these types of problems will be asking you to find all 6 trig functions. Well, they give you 1, so we have to find the other 5. All you need to do is figure out, and I'm so sorry, this is not 1, but -1 and -1. Why? Because they told us that sine is less than 0, and we know that that is x, and cosine is less than 0, that is y. So both of those must be negative. That's super important because that will change what our sine and cosine is. So just make sure that we remember that these are positive or negative depending on what quadrant they're in. Any questions on that? Give me a thumbs up if that made sense. Okay. And then Helena, did that make sense?
Yeah, that makes sense.
Okay. All right. We're going to talk about our next big thing. And I'm going to try and go through this not too quickly, but I want to make sure that we get to this whole guy. So for homework, you guys will be doing this. And this is going to be filling in our, oops, let me make sure that my iPad is linked so I can share this. Here we go. We're going to be filling in our unit circle. All right. What is a unit circle? Our unit circle is a circle on our plot. So this is our X and our Y axis, where the radius equals 1. This is super important. Why? Well, because what did we learn up here? We learned that if our radius equals 1, the x coordinate is cosine, and the y coordinate is sine. That's super useful, because if I want to figure out this guy right here, let's say I tell you that this is 30 degrees. Well, then guess what? This x coordinate is cosine of 30 degrees, and the y coordinate is sine of 30 degrees. I'm going to make a little table of all of the reference angles we care about. So here are our reference angles. And these are the only ones we're going to have to memorize. The unit circle needs to be memorized. This is super, super important. And for homework, you guys are going to fill in the unit circle and really, really, really work towards memorizing. So our reference angles we care about are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You will need to know things like 135 degrees. But guess what? You don't need to memorize what happens at 135 degrees. You need to take 135 degrees, find the reference angle, which 135 degrees is just, 180 minus 135 degrees. That's going to be our reference angle, and that's just 45 degrees. So as long as we memorize 45 degrees, we can do any of these other ones that are not in quadrant 1. So really, we're just memorizing quadrant 1. And let's write down what each of these are. For sine of each of these angles, at 0 degrees, it's 0. At 30 degrees, that's going to be 1/2. At 45 degrees, that's square root of 2 over 2. At 60 degrees, square root of 3 over 2. And at 90 degrees, that's equal to 1. Cosine of theta is going to be at 0 degrees, 1. At 30 degrees, square root of 3 over 2. At, no, that's correct. Yeah. At 45 degrees, square root of 2 over 2. At 60 degrees, 1/2. And at 90 degrees, 0. Very, very last one that we need to talk about is tangent. And tangent we know is 0 at 0, square root of 3 over 3 at 30 degrees, 1 at 45 degrees, square root of 3 at 60 degrees, and it's undefined at 90 degrees. All right. Here's what we, the best way I like to remember this is I like to memorize just sine. Because guess what? Sine is the exact same thing as cosine, but backwards. Sine goes from, we go from 0 degrees to 90 degrees. Sine goes from 0, 1/2, square root of 2, square root of 3 over 2, and 1. And guess what? It counts up. Look at the numerator. That's 1. This one is square root. And in fact, you can even pretend that this one is a square root too. They're all square roots because square root of 1 is just 1. So to memorize this, I like to go, oh, this is 0. The next one is 1, then 2, then 3. And they all have square roots. And they're all divided by 2. And then, of course, 90 degrees is just 1. To do cosine, it's the same thing, but backwards. See, it goes from 0 to 1/2, square root of 2 over 2, square root of 3 over 2, and 1. You technically don't have to memorize tangent because how do you find tangent? Well, you do this one divided by this one. This one divided by this one gives you 1 over square root of 3. And when we radicalize that, we get square root of 3 over 3. If you happen to be really good at memorizing things, and I would still recommend to try and memorize this as well, it'll save you a lot of time in this class. But let's just remember that quick memorizing note. For sine, it's going to be first to last. It's going to count up. So 0, 1, and they all have square roots, right? So 1 over 2, square root of 2 over 2, square root of 3 over 2, and then it goes to 1. Cosine is just last to first. It just goes the other way. And of course, we know that tangent is just sine divided by cosine. All right, so for homework, I want you guys to fill in your unit circle. And here's what we need to remember. There's only one extra step that we need to do. We need to, when we're not in the first quadrant, so the first quadrant's easy. I'll fill those in for you right now. This is our 30-degree angle. And I'm actually going to write it like this. I'm just going to write this is 30 degrees. This is 45 degrees. This is 60 degrees. Here is 90 degrees. And let's not forget 0 degrees. We also need to make sure that we're keeping track of the radians. So convert everything to radians. That's 0 radians. That's pi over 6 radians. This one right here is pi over 4 radians. This is pi over 3. And this is pi over 2. You will do the same thing for this guy right here, which is 120 degrees. This guy right here, which is 135. This guy right here, which is 150. And this last one, which is 180. And I'm going to just fill in the degrees for each of these. Your job will be, for homework, to convert everything to radians. So all of these ones to radians. And that's what these blank spaces are. So this is where the radian goes. This is where the degree goes. And this is where your sine and cosine goes. Let me write the rest of these really quickly. Right here is going to be 210. This is 225. This is 240. Here's 270. Here is 300, 315, and then 330. And how do we actually figure this out? Well, we've already memorized the first one. We memorized that cosine of 30, which is the x, is going to be square root of 3 over 2, comma, 1/2. In the middle, it's square root of 2 over 2 and square root of 2 over 2, right? They both have the same one. Right here at 60 degrees, well, that's 1/2, comma, square root of 3 over 2. It's just the opposite at this point. Sorry, I keep skipping 0. But 0 degrees, well, that's 1 along the x and 0 along the y. And at 90 degrees, well, that's 0 along the x and 1 along the y. Here is what we need to know about all of these other quadrants. Guess what? 120 degrees, find the reference angle. I'll give you a hint, or I'll do this first one. The reference angle is 60 degrees. Well, guess what? Whatever the reference angle is, that's your answer for this right here. Guess what? It's the exact same. It's 1/2 and square root of 3 over 2. There's just one thing that needs to be fixed. That's whether it's positive or negative. Well, the x-axis is negative in this quadrant, so that one must be negative. Is the y-axis positive? Yes, so that one stays positive. And that is my point for 120 degrees. That's what this point is right here. It's negative 1/2 square root of 3 over 2. Can everyone give me a thumbs up if that made sense? I know that was very fast, but I needed to make sure we got to that today. Helena, did that make sense to you?
Yeah, it made perfect sense.
Okay, so let's do one example together and then we can go. Let's do 150 degrees together. First thing we need to do is find that reference angle. Or actually, let's do a different one. Let's do, sorry, this is supposed to say 330 degrees. Let's do 330 degrees together. Let's start with Isa. How do we find that reference angle? What equation do I need to use to find that? I'm told it's 130 degrees is my standard angle. That's measuring this way. That's 330 degrees. How do I find the reference angle?
Is it 360 minus 330?
Exactly. And what does that equal to?
30.
Perfect. So let's take a look at 30. What does 30 degrees tell us the point is equal to? So this point right here must be equal to what? What is the x and the y? Or we can use the chart that we wrote down. It's going to be the same as whatever 30 degrees is. What do we know about 30 degrees? What does this point say? What is the x and the y?
Uh,
So
uh,
the x is going to be, that says square root of 3 over 2. Okay. And what's the y point?
1/2.
The only thing that we have to do here is figure out, well, is cosine positive here? Is our x positive in this quadrant? We're in quadrant 4. Is x positive in quadrant 4?
Yeah.
So that one's good. What about y? Is y positive or negative?
Negative.
So I need to change that to be a negative. And now this is the point. That's the exact measurement of that point. Any questions? So for homework, we're going to be filling in all of our unit circle. And we're also going to be, there's a worksheet that says 4.3, page 251. We're going to be doing, so for homework for 4.3, it should say page 251. You're going to do 1 through 8, but skip number 4. And then you're going to do 17 through 24 and 33 through 40. Okay, so this is the first homework. And then the second homework is going to be to fill in our entire unit circle. Okay, and when I say fill in, I mean you're going to write, right here is going to be 30 degrees, and right here is going to be whatever the radian version of that is. And then you're going to put your x coordinate and your y coordinate here. Any questions on that? Everyone give me a thumbs up if that makes sense. All right, and then Helena, did that make sense?
Yeah, that makes sense.
Okay, awesome. Let me stop the recording.